Hi, my name is Haley Kinoshita.
And I'm Brett Swan.
And for our data science CPSC 392 final project, we wanted to see if the k-means clustering algorithm could identify different segments within the automotive market when given raw specifications. So for this, we decided to look to Edmunds.com. And for those of you who are not familiar, Edmunds has reviews, editorials, owner ratings, and car comparison tools that a user may want to use before buying their car. So just like Yelp, Edmunds has an API available for developers who wish to access their information.
So this is the Edmunds API. There are a whole wide range of requests that you can make, and each one of them returns a JSON formatted text file, which can be manipulated in any kind of text editor. And so this past summer, I wrote an application which revolved around solely the Edmunds API, and so I needed all of their data. And so to do that, I wrote this little function here that pulls everything from their site, and then further down in this application, it exports it all to a CSV. This is our resulting CSV from the program that I'd written. And this is 22,000 rows. It's 282 megabytes, and it has 24 attributes, but we didn't need all of them. So we wrote another small Python program that eliminates a couple of these columns that were deemed superfluous, and that resulted in this.
For this project, we decided to look at only cars that were made in 2015, which gave us about 1,200 rows, and also we slimmed it down to 18 attributes. Those attributes being make, MSRP, horsepower, peak horsepower, torque, peak torque, displacement, fuel grade, highway mileage, city mileage, transmission type, number of gears, vehicle size, vehicle style, number of cylinders, driven wheels, number of doors, fuel types, and aspirations.
So at the bottom of this CSV, we noticed that there was a segment that was missing its MSRPs, and upon inspection, we noticed that it is mostly very high-end vehicles. So we have Rolls-Royce, Bentley, Aston Martin, Ferrari, Lamborghini, Porsche, and so these values, because they're missing, Weka will automatically fill in with the mean MSRP from this whole data set. So that's automatically going to bring down this segment when we're doing our clustering as far as MSRP. Moving from the CSV into Weka, we ran our simple k-means algorithm 9 different times for 2 clusters through 10 clusters.
And to pick which cluster would be the best for our data set, we looked at this graph, which graphs the number of clusters and the sum of squared errors. And we decided that either 4 or 5 clusters would be the best based on the slope of this graph.
Now, when we were looking at the 2 different options, we noticed that our 4th cluster here was pointing to a segment of the market that didn't really exist. There aren't really these high-powered front-wheel drive coupes. That doesn't really exist in the real world. So when we checked our results with 5 clusters, we noticed that this is a little bit more representational of what we actually see. We see our 2-door hatchbacks with front-wheel drive, lower power figures, lower MSRP. So that makes a little bit more sense, and so that's where having the domain knowledge is really helpful.
So ultimately, we settled on 5 clusters because of this, and because when we looked at each cluster, we could think of a car that generally fit this specification. So for our first cluster,
we have the large pickup trucks, and so we've got about 350 horsepower, 360 foot-pounds of torque, 5 liters, a little bit over 5 liters of displacement, running flex fuel, 25 mpg highway, 18 city, and we've got rear-wheel drive, naturally aspirated. So this actually perfectly lines up with our Shelby Silverado. We've got 16 and 23, a little bit low on those. However, everything else is pretty spot on. We've got rear-wheel drive, 5.3, 355 horsepower to 349, 383 foot-pounds of torque to 366. Moving on to our second cluster, this would be our compact, lower-end, smaller SUVs. So that is like our Toyota RAV4. Cheap, naturally aspirated, front-wheel drive, low power, lines up really well. Then we have our like mid-range sports sedan. So this would be like your BMW 3 Series. That lines up pretty spot on, right around 300 horsepower. Really, really close for our MPG as well. And then we move on to our sports coupe segment. So this is what we were talking about earlier. This is a little bit more of a high-end category. So we've got our starting price of $58,000. This is probably our most expensive segment. So this would be like your Porsche 911s, your Corvettes, your BMW M cars. This would all fit into here. And then our last category is our hot hatchbacks. So this would be like our Ford Fiesta, Ford Focus, VW GTI. That all fits into here perfectly. You got front-wheel drive, turbocharged, around 200 horsepower. So it's really kind of remarkable to see how well such a simple algorithm can identify the kind of ambiguous market segments, and we're really pleased with the results.
And just one of the things that we noticed that was kind of peculiar with the MSRP was how low it was compared to market price, and we concluded that was because we picked 2015 models that the car loses its value, just depreciation, over the years. We're concluding that we can in fact use k-means clustering to identify different segments within the automotive market.
Thanks for watching.
Drive safely.